I'm just saying for those with a blank page, your S is 120 from the right side, 100 from the top. That's where you get your starting position. Then, I'm repeating again, please do not stay home. We have 3 more course drawings to do, and we need to finish your part. After that, you can do as you please. But I need those things before you disappear. The what? Oh, the page 1226 has a mistake on it. So it's not a course string, we're going to do 1225. And then, no, so far we've done mechanical development, and then we're going to do this one. Then there's 2 things from a new topic that I should still teach you. Yeah. So that's why my grey hair ages me by 20 years. Yeah. So we need to draw. You need to have your things here. We need to finish this today. Okay. Yes, please. So specifications, it means you need to listen, you need to focus, and you need to draw with. Okay, specifications, the follower reciprocates on the vertical center line of the camshaft. So it's going to be over there. Then the minimum distance from the camshaft center to the cam profile is 17. Rotation anti-clockwise. So in which direction do we number? Clockwise. Okay, motion I'll go over in a minute. Instructions draw to a rotational scale of 30 degrees is equal to 8 millimeters, and a displacement scale of 1 to 1. The complete displacement graph. Label the displacement graph and include the scale, draw to scale 1 to 1, the given camshaft, and the wedged shaped follower. At the minimum distance, project and draw the cam profile from the displacement graph and show all directions of rotation on the cam profile. Show all constructions. Okay, so you'll see your follower is at the bottom this time. I'm going to draw it as I see it here. So my camshaft is 14 in diameter. Thank you very much. Okay, you need to use a circle that is radius 7. 100, 120. I am cheating because I can. I'm using 15 because I don't have a 14. The camshaft also needs to be hatched. Yep. 14. 1, 4. Radius 7. Okay, then our instructions tells us that the minimum distance from the camshaft center to the cam profile is 17. So from the center to where the profile is going to start is 17 millimeters. So from the center I measured 17 millimeters down. 17. From the middle, 17. And then rotation is anti-clockwise. Your instruction says this wedged shaped follower is 8 millimeters. So from the circle I'm going to measure 8. This is the minimum size that it can be. The smallest piece. Okay, so from here it's 8 down. Then okay, then it goes down 56. Yeah. 56. Yeah, from the 8.
Good, man. I think you saw what happened in the morning. I think you saw what happened in the morning. The fights and stuff.
We're going to start in the evening. 12:26. I'm drawing on a blank page. You can take a blank page if you need one. You can take a blank page if you need one. Are you okay? Okay. The what? Sorry? Okay, so from here it's 17, 8, 56. Yeah. 17, 8, 56. From here it's 17, 8, 56. Okay, they don't specify the width. Let me just see something. Which means that if I just take this 60 degrees from where the wedge follower starts, it will give me the width. Just from the 17 to the 8, 17 to 8, and that is then my width. Okay, then to draw our displacement graph. So Our follower is at the bottom, so basically our graph is going to be upside down. Okay, but the step still stays the same. Okay, it says in your instructions that 30 degrees is equal to 8 millimeters. So we need 12 8 millimeters. What's 8 times 12? 96. 96. Anywhere on the left where you feel you will have enough space to still draw your cap. Yeah. Okay, it's 8, 16, 24, 32, and then 40, 48, yeah, 64, 72, okay, the rest I have. Thank you.
What's the width for the roll?
If you just put your 60 degree until it touches the line. That's your line. And I have evidence for you on recording. The what? Zoom in. In. Okay, so I am labeling displacement graph, rotation in millimeters, and as soon as I have the height, I'll be able to label the bottom. I also labeled my cam profile. Okay, looking at the instructions, it says it descends 56 millimeters, then it rises 20, so it goes down 56, 20, then there's a dwell period, then it returns. So 56 is our longest line. Yeah. 56. $56. Yeah. from here it's 56 down. 8. 12. 96. I'm also lost. Yeah. In life. Okay. We are found. It needs to be 360. You need one for 0, one for 360. 8 millimeters. Oh, okay. Okay, can I continue to do the graph? Okay, so it descends 56 with a uniform acceleration and retardation during the first 180. So by 180, it needs to be by this point. So we will need to... Sorry? 56. We will need to apply the retardation and acceleration process in this space. So we have 1, 2, 3, 4, 5, 6 slots. 6 from 0 to 180. Which means I need to divide this into 6 equal pieces. So I'm drawing a line that is any length, any degree. And I'm going to divide it into 6 equal pieces. I'm using a centimeter. 1, 2, 3, 4, 5, 6. Six. Any degree, any length, 6 equal pieces. Yeah. Any degree, any line, or any degree, any length, then it's 6 equal pieces. Anyway. Okay, then I'm lining the last piece up with my 0 corner. Putting another ruler at the bottom of my triangle. And I'm moving it so that I will have parallel lines. Okay, then I'm going to look at this middle piece. This will be my guideline. It's up to 180. All of it. Have you divided this into 6 equal pieces? No, because I don't know where they come from. Okay, so then after you've divided your line, you've projected it to the side, then I need you to draw a straight line going to 180. Straight line to 180. Yeah. I am going to focus on the middle lines. Just straight. With your board ruler. Yeah. Can I continue? Okay. So, it says it accelerates and retardates when it meets 180. So it will mean from 0 it's going to accelerate and then retardate. So for the acceleration, it's going to start by 0 and it's going to end in the middle before it slows down. Light line. It is going to, at the end of the day, be a straight line. Goes from 0 to the middle. If you want to, you can draw a straight line through.
So we can go from 0 straight
to 180. Okay? Then every spot in between, I'm going to connect 0 with that as well. Just in the first quarter. So So I'm just drawing a line from 0 to each line. Then I needed to end here. I already have this line. I'm going to do the same for the bottom. We didn't finish the one last time. We ended in the middle. Yes. It's just turned.
Upside down.
So, do you have these lines upside? From the middle. I needed to start here, so it's going to accelerate up to there, and then it's going to just slow down. So for the acceleration, I'm just connecting from where it needs to start to where it needs to go. Same. Yes. Okay, then need to quickly focus. Focus. So when I'm plotting my points, I'm going to start here by 0. I'm just going to get a darker marker. So this is where I'm starting. Then I'm going to move to 30 and where it crosses the first line. So this is my next point. Then for the 60, I'm going to where it crosses the second line. So I'm moving one line up, one line down the whole time. So from 0 it goes to 30, and then where it meets the first line. From 60, where it meets the second line. 90 will be in the middle. So I'm just showing the first section. Freehand. Same with the bottom. It needs to end here. So I'm going to go to 150 and where it starts. So where's the first line?
And does it change? Does the technique change?
No.
It will always remain like this.
Always the same. Then 120, second line, and then 90 will be in the middle.
So does one line doesn't get plotted twice?
Yeah, 90 does. Okay, we'll continue next time. Yes, please. Please leave it in class. Please write your name on. I'm gonna leave the box here in front of you. Make sure your name is on.
And this is the first